Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 7 to the power of n minus 11 to the power of n over square root of 77 to the power of n minus 121 to the power of n equals to 1, and we will solve this problem for the values of n. So the very first thing we are going to do is here first we rewrite this equation as 7 to the power of n minus 11 to the power of n, and this whole over square root of, you have 77, and we will write it as 7 times of 11 and its whole power n, minus here you have 121, and we will write it as 11 squared and its whole power n, and it is equals to only 1. And in the next step we need to more simplify this equation, so that here we write it as 7 to the power of n minus 11 to the power of n over, here we separate the exponent on both of the terms, and we write it as square root of 7 to the power of n multiplied by 11 to the power of n, minus here we interchange these two exponents and we write it as 11 to the power of n and its whole squared, and it is equals to 1. So in the next step we need to simplify the terms, so that here we just take a equals to 7 to the power of n and b equals to 11 to the power of n. So when we put the values of a and b on this equation, then it will becomes in this form, and we have 7 to the power of n, so we put here a, minus we have 11 to the power of n, and we put b, and this whole over square root of 7 to the power of n, it is a times of 11 to the power of n is b minus b squared, and it is whole equals to 1. And now in the next step we will take the square on both of the sides, so that it will be looks like in this form, and here you have the square on this side. So now we will just take the square on the upper term and its lower term, so it will be written as in this form: a minus b whole squared over, you will just write it as ab minus b square and its whole squared equals to 1. You know that the square of 1 equals to 1. And in the next step we will just simplify the terms, and we write it as a minus b whole squared whole over, you see that these 2 and square root are gone, and we get here ab minus b squared equals to 1. So in the next step you will just multiply both of the sides by ab minus b squared. So when we multiply both of the sides by this term, then we will get its output in this form, and you have ab minus b square is multiplied by a minus b whole squared over ab minus b squared equals to 1 is multiplied by ab minus b squared. So now you see here we have this term is cancelled out by this one, and you will get here a minus b whole squared equals to, you get in the right hand side ab minus b square. So now we move ab minus b square in the left hand side, and you obtain a minus b whole squared minus ab minus b squared equals to 0. So you will just write a minus b whole squared minus, here we take common b and you obtain a minus b and this whole equals to 0. And now in the next step you will see here we have a minus b be the common term, so that we will take it common and you obtain here a minus b, and here we get minus b and this whole equals to 0. So that here we have two cases. The first case is we write a minus b whole equals to 0, and the second case is we write a minus 2b equals to 0. So in this case you will easily get the value of a is equals to b, and here you get a equals to 2b. And now in the start of the problem we will take here a equals to 7 to the power of n and b equals to 11 to the power of n. So we will back substitute these two values here. So when you put a equals to 7 to the power of n and b equals to 11 to the power of n, and similarly here we write 7 to the power of n equals to 2 multiplied by 11 to the power of n. So now in the next step we will divide here both of the sides by 11 to the power of n. So it will be looks like in this form, 11 to the power of n and 11 to the power of n. So these are gone, and here we can just combine the exponent of these terms, and you write it as 7 over 11 and its whole power n equals to 1. Similarly we will move here 11 to the power of n in the left hand side, or we divide both of the sides by 11 to the power of n, and you see that these two terms are gone, and here we just combine the exponent and you write it as 7 over 11 and its whole power n equals to 2. And now in this case we have 7 over 11 and its whole power n, and we write this one as 7 over 11 and its whole power 0. So here you see that the bases on both of the sides are same, so that we will equate its exponents, and in this case you will get the value of n equals to 0. So this is our first solution of this problem, and now in order to find the other solutions we move towards this equation. So in this equation you will see here we will take the log on both of the sides, so you get log of 7 over 11 and its whole power n equals to log of 2. So now we use the property of log and we move this exponent n in the front of this log, and you get n times of log 7 over 11 equals to log of 2. And here we again use the properties of log, and you write it as n times of log 7 minus log of 11 equals to log of 2. So here we move this log the terms including log in the left hand side to the right hand side. So we will get here n equals to log of 2, and this is divided by log of 7 minus log of 11. So here we use the logarithmic table or calculator in order to find the values of log. So you see that log 2 equals to 0.3010, and the value of log 7 is 0.8451, and the value of log 11 is 1.0414. So these are the values of these logs, and now we will add or subtract these values and divide it by these values. So finally you will get here the value of n equals to minus 1.5334. So this is the other root of the given equation, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.